Humbart here. I do not recommend this video for the general physics crowd, as most of you have not taken calculus, so I'm going to preface this video by saying that right now. For the other people, though, that are curious about this, I will be deriving these equations from the ground up with some calculus. Alright, to start, we'll talk about the definition of acceleration. We know acceleration is some change in velocity over some change in time. And if we take the limit as delta t approaches 0, we'll get this minuscule amount, this dv dt. That's how we get introduced to calculus. And here we're going to put dt in both sides. So dv, remove that there, a dt. It's a little weird to do so, but it's possible. Right. And we're going to integrate from v initial to v, and 0 to t. Once I do that, I'll get v minus v initial, since there's nothing I'm changing. Integral. This is going to be a and t. And here is where I get my first form, which is just going to be v, v equals v0 plus a and t. Draw the a little better. There we go. All right, now we also want to find the next version, so we can break up this v and to do kind of a similar thing here. Do some change in x over a change in time. Take the limit. Delta t approaches 0, and we get dv, or dx, not dv, over dt. Alright, this time around we'll multiply, put dx equals v dt, like so. And I'm going to integrate from x initial to x, and from 0 to t, and I'll plug in what v is, which is going to be b initial plus a times t. So this one, I'll get some x minus x initial equals v initial t plus 1/2, because t squared over 2, a t squared. And that's another equation I've just derived. Alright, the final one, because we know velocity is dx dt, we're going to do something with that initial equation. So instead of making acceleration dv dt, I'm going to make acceleration, put dv dt, but I want to do something else. This is a little trick. Put dx over dx, and we'll get rid of the time here. So we're going to turn this into dv dx, and then dx dt is acceleration, or velocity, so I'm going to put the velocity here. So v times dv over dx. Alright. Because I can just switch those multiplication. Let's multiply together, so I can just switch those around. Now that I did that, let me put the dx over next to the a. So multiply both sides by dx. V dv. Then I'm going to integrate from x initial to x, and from v initial to v. And we're going to get some a x minus x initial, or delta x equals v squared over 2 minus v initial squared over 2. And we could put the 2 over there if we wanted, but I'm going to leave it there as is. As you can see, we can get back to our original form that's usually in text. So those are 3 equations derived with calculus, and that's it.